Today we are building this quad. This is a budget build with a total cost less than €150. However, it features F7 flight controller, 60 amp ESC, T-motor VELOX 2306 motors. So I think it's a very good list of components for this price. So if it's something interested, please stay tuned and let's start the build. The frame I'm using for this build is a budget Mark V frame, which you can get for around €29 with all 3D prints included on AliExpress. I already have a video on assembling this frame, so I won't go over that here. This one is pre-assembled, but I'll leave a link in the description and add a card on the top of the video for anyone interested. For the motors, I'm using T-motor VELOX 2306 motors. They cost about €35 for a set of 4, so less than €10 per motor, which makes them a solid budget option. I originally planned to get 1750 kV version for this build, but I accidentally ordered 1950 kV ones instead. That means this build is going to be a bit more of a monster than I intended. The stack I'm using comes as a full bundle. It includes the ESC flight controller, VTX and camera, altogether for about €80. The flight controller runs an F7 processor, specifically STM32F765 chip, and the ESC is rated at 60 amps. The stack itself is about €60, which is pretty typical for Chinese F7 stacks, but the real value here is that it comes with both VTX and camera included. Overall, that makes it a great deal for building a budget quad with an F7 processor. The VTX included in the kit looks like a standard analog VTX. I have a similar one called the Cyclone, while this one is branded B-CUBE. Functionally, it works fine. The only real limitation is a dipole antenna that comes with it, but since we are keeping this build under €150, I'm going to stick with it rather than upgrading to a more expensive antenna. As for the FPV camera, it's branded Mista. I couldn't find much reliable information about it online. Some listings even claim it's 2000 TVL, but that's clearly not accurate. Realistically, I'd guess it's closer to 600-800 TVL based on typical cameras in this price range. AliExpress listing for the kit actually shows different camera in the photos, so I'll just have to test this one out and see how it performs. Finally, ELRS Receiver. It's a basic ELRS unit with power amplifier and low noise amplifier. It comes at around €8. It's much cheaper than most of other receivers, so I think it's worth trying in this build. Putting it all together, the motors come to about €40, since the set itself is around 35 and shipping adds another 5. Even with that, they're still one of the best budget-friendly options with solid quality. The FPV bundle, which includes the flight controller, ESC, VTX and camera, costs about €80. The ELRS receiver is around €8, the frame is $29 and the props at about €3. That brings the total build cost to $147.87, which keeps us under $150 mark. Keep in mind, these prices already include Irish VAT at 23%, so if the VAT in your country is lower, you can build the same quad for even less. Before we begin, I have to admit I messed up. I mounted the ESC upside down, so what you are looking at as the top is actually the bottom. There are tiny motor markings near the pads, which I highlighted in a red circle. I didn't notice it at first and only realized it when I powered up the motors and the order was completely wrong. I thought about redoing the whole setup, but in the end I just decided to reorder the motors in Betaflight instead. Just lazy, I know, but it works. We'll start with soldering the capacitor. I added a bit of a flux and solder, and the capacitor was done. Next, I tinned the XC60 connector wires and then tinned ESC pads. Then I soldered the XT60 connector. For this you'll need quite a lot of heat, around 400 Celsius with good low temperature solder wire to get a solid connection. Once everything was soldered, I cleaned the pads with a soft cloth. Now let's tin the motor pads. I applied some flux on each pad, added a bit of a solder and prepared them. This is how ESC looks fully prepped, again upside down, but that's fine. After that I mounted the ESC to the frame. Before we continue with the build, I have to say that flight controller and ESC, they come in plastic bags like that with zero hardware, so you have to have all the screws by yourself. That's the downside of cheap stacks. And for this build we will need some of M3 screws, they are all available in this pack. And we will also need some M2 screws to mount the camera. So I'll put links to those screws in the video description just in case you need them, but I think if you are in DIY, it's an essential stuff to have. Once the ESC was in place, it was time to mount the motors. For this I used M3x10 screws, 16 in total, and added a drop of blue Loctite onto each screw to make sure everything stays tight. With the motors mounted, I trimmed the motor wires to the correct length, stripped just a couple of millimeters off the ends, and soldered them to the ESC pads. At first I used a smaller soldering iron, but later I switched to a bigger one for better results. Once all the motors were soldered, the quad started to take shape. I connected it to a smoke stopper for testing and everything looked good, no shorts, so we are safe to continue. Next, it was time to add the flight controller. One thing that confused me during the build was the cable between the ESC and the flight controller. I didn't want it twisted, and that was one of the reasons I messed up with the top side of the ESC. At the end of the day, the cable is not twisted, the flight controller is in place, motors are reordered, so all good. At this point, if you're still watching, you're probably like me, you prefer building quads rather than buying them, so I dare to ask for your support. Please subscribe to my channel, like, put any comments, this will help me to grow my channel. Thank you very much. I also want to remind you that all parts used in this build, as well as some tools and accessories, everything is listed in the video description down below. Now it's time to set up the ELRS receiver. I start by applying some flux and soldering the receiver wires. Once the wires are attached to this receiver side, I solder them to the flight controller, which I had already tinned earlier. You may notice an extra red wire coming from 4v5 pad. That's because this flight controller only has one 4v5 pad and I'll need to share it with the GPS later on. If you don't plan on using GPS, you can simply solder the receiver directly without this workaround. After soldering around the wires between the flight controller and ESC stack, secure the nuts back in place and keep 4v5 pad wire isolated for future use with GPS. Next I mount the ELRS antenna. I slide on a heat shrink tube, position the antenna so it fits neatly into TPU mount and the back of the frame, and then shrink it with the heat. Wire length is just right, maybe 5 mm short of perfect, but it works well enough. With the antenna secured, I place the receiver into the frame. Before fully zip tying it down, I need to check that everything is working. The next step is to update the receiver firmware and bind it. This receiver shipped with version 3.3.2, so I updated it to 3.6 of ELRS. Note firmware version used on this receiver is Betaflight 2.4 GHz Nano RX. Once updated, it's bound to my transmitter with binding phrase and I'm verifying the connection is successful. In Betaflight, I enable UART2, which is where the receiver is soldered, and confirm that it's receiving input correctly. Everything checks out. For now, I just set up single switch for arming. With that confirmed, I secured the receiver in place with a zip tie around XT60 wires. Now it's firmly mounted at the back of the frame. And that's how the receiver setup looks like at the end. Now I'm preparing the VTX wires. I cut them to required lengths, but we don't need all 6. Only 4 are necessary. The extra ground and 5 volts out wires can be removed. So I carefully release the connector, pull out unnecessary wires, and we are left with just the 4 we need. Then I solder them to the corresponding pads on a flight controller. With that done, only the camera wires are left, so I solder those as well. Next, it's time to mount VTX. Normally, I'd install it with connector facing forward and the antenna mount facing backward, probably using a straight MMCX connector instead of an angled one, but since we are sticking to a €150 build, there is no budget for a different antenna. To make it fit, I rotate the VTX by 45 degrees so the connector and antenna sit at the sides. I'm using M3x20 screws which came in the kit I showed earlier, and I secure the VTX with nylon nuts from my own stock. Once that's in place, I plug the connector. For the antenna, I designed a 3D printed a TPU holder. I'll leave a link to Thingiverse in the video description if you want to download it. That holder secures a dipole omnidirectional antenna neatly in the frame. Next, I install the camera cage which I already pre-assembled. I mount the camera inside using the inserts provided with the frame. The inserts I'm using have 2 holes, and I mounted the camera in the furthest position so the lens sits recessed and well protected by the cage. As you can see, the camera lens is now safety shielded. Before I put on all top plates, let's check the quad with smoke stopper. Okay, so we have OSD, we have Betaflight menu shown on screen, so our smart audio is working. That's fine. Camera is working. So I think we're good to go. One last thing we need to check is if drone is actually arming, and I'll do it now just without smoke stopper. Just remove smoke stopper.
Telemetry lost.
And plug in battery directly. Okay.
Telemetry recovered.
Okay. And check props directions. Props out, props out, props out, and props out. Okay, I think we are good to go. We are good to close top plates and do some final Betaflight setup. I also decided to mount a GPS module. This isn't part of a core build, but I'm adding it so I can measure speed and maybe play around with features like position hold or altitude hold later. I designed another quick TPU mount for it and secured it on the top of the frame in place of an action camera mount. Now the quad is fully assembled with all components in place. To finish up, I've wrapped some mechanical and electrical tape around the arms to hold the wires securely. This also adds protection in case of broken arms, helping to keep wires safe. Now it's time to move on the software setup. First we need to flash the ESCs. They come with BlueJay firmware, which doesn't support bidirectional D-short, so I am reflashing them with the latest version of BlueJay. For the motor PWM frequency, I select 48 kHz and click flash. I've already done this before, so you can see the ESCs are now running BlueJay 0.21 with a PWM frequency of 48 kHz. Next, I'm flashing the latest Betaflight 2025 pre-release firmware onto the flight controller. During the flash process, pick analog OSD, and also if you have GPS, include altitude and position hold, along with standard firmware options. Once it's done, we can jump into the Betaflight configuration. We will start with the VTX table. The table is available on GitHub from B-CUBE, so I simply copy the existing profile and import it into Betaflight. I put the link to GitHub repo in a video description, so you can go and download yourself. In my setup, I always use raceband channel 1, so I configure that here. I also enable low power mode when disarming, so VTX doesn't drain the battery unnecessarily. Next, let's go to the other important tabs. Ports tab. UART2 for receiver, UART4 for GPS, UART6 for smart audio, which allows the flight controller to talk to VTX. Configuration tab. Pid loop and gyro loop both set to 8 kHz. Arming angle set to 180 degrees, so we can arm from any orientation. Enable all beeper related options. Pid tuning tab. I use a rate profile tree which is similar to the default Betaflight rates, but with a little extra expo. This makes the stick smoother around center while still giving sharp control at the ends. Receiver tab, standard setup, nothing special here. Modes tab, I configure my usual switches layout. Motors tab. I set props to spin props out mode. I also enabled bidirectional D-short, and I also set dynamic yield earlier in pit tuning tab, so this improves stability and gives more precise control during sharp maneuvers and minimize prop wash. And that's it for Betaflight configuration. I'm currently in a park preparing for the first flight. This is a quad. I'm warming up GPS, and here's my goggles, and I will use my old goggles as a DVR because this one doesn't record DVR in analog mode. So let's see what we can do. I'm starting with small circles around my position, keeping the quad close so I can easily recover it if something goes wrong. Right away I noticed that the FPV camera seems to have a bit more latency than usual. It feels slightly delayed compared to standard analog setups. Also, the DVR footage looks worse than what I actually saw in the goggles. That's probably because the DVR was on the ground. I should have mounted it on a tripod for a better signal, but it's fine for now. On the first flight I got about 7.5 minutes on 6S spec, which is pretty standard for this kind of setup. Now I am swapping in another 6S battery for a second flight to do some speed tests and a bit of freestyle. The quad flies great, really stable and responsive, though I did notice a few minor signal drops in certain orientations. During the speed runs it turned out to be crazy fast, definitely more powerful than I expected for €150 build. ELRS Receiver has shown really good performance, no major drops on RSSI and link quality. I've wrapped up with some easy cruising and I realized I flew a bit longer than planned. You can see my battery discharged much more than allowed. My current sensor isn't calibrated yet, so I'll need to fine-tune the amperometer later to get accurate power readings. But overall, an awesome maiden flight. I've flown to park on this, and I must say I'm quite happy with the build. There are some minor things with this build, like little bit latency on the camera, and this antenna definitely needs to be replaced to something better. But overall, like F7 processor, 60 AMP-AC, and you've seen it can be very, very fast. So I would say to fly in a park, this is like more than enough. If you are going to fly bando or other stuff, you better need to think about better camera and better antenna. Overall, that's it for today. At the end of the day, I'm happy I can recommend this build, and thank you for watching. Please like, subscribe to my channel, and see you in the next videos.